My name's Alyssa, born and raised here in San Francisco, a bit of a data nerd, been doing product management in AI for about the last 5 years or so. At the moment, I'm at Figure 8, really excited about what we're doing. I'm solving my own problem that I had at Watson because I could not possibly have scaled what I needed to achieve without tons and tons and tons of training data. And so at Figure 8, what we are all about is creating large scale volumes of training data in the real world, in reality, for our customers. So I got into AI because I was on a flight. I was working at IBM at the time at a different area, and I was on a flight back from London. I was a little bored and annoyed at my job, and my boss was pissing me off. I'd spent a week with him. He's great, but when you spend a week with your boss, you're done. And I was seated next to a woman, and she gave me some career advice, which has stuck with me. She said, "Go solve the hard problems. Everything else will work itself out." And I looked around and I thought, hey, this whole AI thing, hard problem, hasn't been solved yet. And I don't know anything about it, but I was lucky enough to get a job in the IBM Watson division to help turn what had been a very sort of academic pursuit into a real business and a real product. And I did know something about product management. And so I was able to tackle the computer vision suite at first. And one of the first products that we released was this ability to do sort of custom visual recognition classifiers. And one of my very first beta clients ended up being a company called OmniEarth. And if you haven't heard of them, they do sort of sophisticated modeling using satellite images. And their first project that they were struggling to scale back at the time, this was 3 or 4 years ago, was around drought in California. So who remembers the drought here about several years ago? Not a lot of water, it was a big problem, we produced a lot of food. And so the state of California had mandated that you needed everyone to use less water. And the challenge was who uses the most water, because the infrastructure was super old and no one knew who was using the most water. There was not sort of great monitoring in traditional ways. And so what they were doing at OmniEarth, they were taking satellite imagery and they were breaking it down into small little parcels of land, and they were using a visual recognition classifier to determine, hey, this lawn is too green, or this lawn is brown, it's not being watered, or hey, you have a pool in your backyard, you're using a ton of water. And so they built out this sort of dashboard that combined mapping data with water usage data. And the first thing they did for Maricopa County, the government down in Southern California, the guy at the water district, right, whose job it is to reduce water by 20% in his county, he goes and looks up his home address. And of course, he is using too much water. He did not know that there was sort of a leak in his backyard. He was overwatering his lawn. Anyway, so I got kind of hooked on solving real world problems using AI, in this case, which was a very, very sort of simple visual classifier, but a really big impact in terms of how they could understand something different about their world. So I got pretty excited about it. OmniEarth ended up getting acquired by another company called EagleView because of this sort of narrow but very successful application of AI. And I was like, wow, this is something we could really change the world on. So there's a lot of hype in AI, right? Everyone's talking about all the magical things that are going to get accomplished, right? Lots of percentages and lots of revenue. In my experience, actually, sort of the reality is pretty far behind the headlines. But it's actually still really cool. So production deployment certainly lags behind. Only about 20% of C-level execs say that they are currently using any AI-related technologies at scale or in a core part of their business. So that means 80% are not, right? Even though they may say they are, they're excited about it, it's probably they have an innovation project or sort of an R&D thing on the side. And a lot of that is because there's not a clear business problem that they've articulated. Often they're sort of hey, do AI. Go, let's add AI into our business. And you're all right, but what does that actually mean? What business problem are you trying to solve? So I always recommend starting with the business problem that you're trying to solve and then working backwards into, hey, is there even an AI problem here? Or is this, sort of a statistical modeling problem? Is this a traditional business analytics problem? Is this something else? And over and over and over again, most AI projects fail because of bad data. Successful projects have very high quality, very relevant data to the business problem that they are solving. It all comes back to the data that we put into it. So who has done this? This is a very typical approach to AI, where you start with the data, you clean it, you transform it, you may build a model, testing, sort of validate, and then end up deploying it. Anyone done this before? Yeah, really common, often taught in many academic settings. What I found is there's a lot of challenges with this model, because you're starting with the data. My slides. You're starting with the data, and you're not starting with the business problem. And so when you go to deploy, you actually may have nothing to do with the real business problem. And so a better approach that we found, actually real companies who are deploying AI to solve a real business problem at scale, is that you start with the business problem. You define what that problem is, right? So going back to the drought example, hey, too much water. How do we get less water, right? You define what the value is of solving that business problem, because that allows you to put resources and actually invest in solving this business problem. Say, hey, it's costing me this much money, right? Or it's costing this problem. Who those stakeholders are, who do you need buy-in from, what is the priority of solving this problem over other relevant business problems, and how do you who's going to invest in this? Only once you've defined those things should you then move on to the data, which is, hey, do we even have the right data to solve this problem in the beginning? One of the mistakes that I made early on was I started with data, and I was like, hey, what business problem does this solve? And it was sort of like I was searching for a problem to be solved with a data set, right? So I started with ImageNet, created some, cool APIs on top of ImageNet, right? Large visual recognition sort of classes, but it's very academic. And the business problems that we had nothing to do with the ImageNet data set. And so if you started with the business problem and then went and got the data, I'd be much more successful. And there's a lot of challenges with the data, right? Is it available, right? What's the provenance of it? Do you have the right security sort of controls on it? Is it cover everything you want to cover? Is it cleaned? Does it need to be annotated or augmented in some way? How often is it going to be refreshed? Because when you then sort of start training a model, often reality will drift from the original thing, and so you need to kind of refresh your data pipeline. So then you can actually build your model, right? And this is the fun part that everyone goes to school for, and I don't know how to build models, but there's awesome people with PhDs that work with actually build the cool models. But this is actually a sort of often can be a very sort of narrow part of the problem. It gets a lot of focus, but it's only sort of one component of it. Then you actually, so who has models sitting on the shelf somewhere? Built a model, not actually deployed. Super common problem. So you actually have to, though, deploy and measure this model in reality against not like an F1 score of how accurate it is, but does it actually solve the business problem that you set out to solve in the beginning? So making sure that you're tying back with those stakeholders, measuring the business value, testing, versioning, often A/B testing different versions of a model, and then actually setting up an active learning pipeline so that you can tune it over time, make sure that there's ground truth, there's success, sort of versioning control. So I'm going to jump into sort of the key here, which is that production systems actively learn. You don't just deploy a model and sort of hope for the best. You actually make sure that you are getting feedback about that model's performance over time and set up an active human-in-the-loop pipeline to be successful. So I'm going to switch gears a little bit and go into a bunch of examples here around who is actually getting value and who's doing this in reality. So these are a bunch of our customers, Eagleview, as I mentioned before. A lot of these are large companies that you've heard of that have many AI projects. But often what's kind of interesting is that the AI project you think they have isn't necessarily what they're doing, right? So we may be helping sort of a large e-commerce company, and you may think it's all about search relevance, but really it's about product merchandising in their warehouse sometimes. So in e-commerce, a lot of the business metrics here around improving search results, improving site conversion. So I'll walk through a couple examples here. I will start with the business problem. And so in e-commerce, for this particular customer, it was around improving site conversion and improving their search results, which actually breaks down into a more narrow problem, which is improving the click-through rate on the top 10 results returned, which actually is an even more narrow problem, which is improving the percent of hero images which featured the product when it was returned. So these are sort of the two categories of images that they had. They had product images, which featured the product by themselves, and they had lifestyle images, which featured the product in context of something. So at Home Depot, these are kind of the different things that you'll see on their website, but what they found is that the product images that were shown by themselves, when those appeared in the search results, those converted at a much higher rate. And so they're like, well, we need to teach a computer to actively display the best thumbnail there so that we can increase conversion rate. And so at the end of the day, that breaks down to teaching a visual classifier, what kind of image is this? Is this a product image, or is this a lifestyle image, or is there something else in our data set that we didn't think of yet, right? What did we not account for? So over and over again, doing this at scale, you can start to differentiate across hundreds of thousands of different product SKUs the difference between a product image and a lifestyle image. So when I bought a house recently, I was searching for a towel bar. I was trying to break this system, and I could not do it. I could not find an example of a product image in search results where there was intended to be a lifestyle image. And as you can see, the lifestyle images are featured sort of differently, not in their search results. So they're having a ton of success with this and deployed at scale across a huge variety of products. So another example here, sticking in the e-commerce space, is H&M. So similar business problem. They wanted to improve site conversion, improve site results, improve the matching on the text string to the product titles that were returned, and then improve categorizing all their different clothing items by filtering on those categories that they had ahead of time. And that was really about improving the percent of products which matched the category search. So if you can imagine, I have 100 products in my catalog, but if only 20 of them are well tagged or well categorized, those are the only ones that are going to show up over and over again. So you need to make sure everything's sort of well tagged, usually in a variety of different ways. Because as you can see, this blazer here, it can be black, but it can also be a blazer, and it can also be women's clothing. So one item can fit into multiple categories. So in this case, we'll take the example of blazer here. So who thinks they know what a blazer is? I'm wearing one. I think everyone's hand should go up. All right, so who thinks this is a blazer? I see like 2 hands. All right, who thinks this is not a blazer? Something else. All right, everyone else. So according to H&M, this is a blazer, right? And basically what you need to do is define in your terms, right, in what you think a blazer is. And then they had a lot of sort of follow-up questions, right? What is the pattern of this blazer? What is the sleeve length of this blazer? What's the fit of this blazer? And defining all these things really specifically so that there's consistency with what they define as the different categories. So another example here is a jacket, right? What's the close of this jacket? What's the sleeve length? So these all become filtering categories that you can look at ahead of time. Because what they found is that the humans who were labeling this, right? So they have new products that come into their warehouse, right, every week, all the time. They're always sort of changing what they're doing. And there's a lot of inconsistency in terms of the human tagging. And so this they found to be a better way of assisting those humans and recommending what those products should be. So again, I went searching for a blazer. I was super easy to find, a red blazer that I was looking for, very well tagged. So switching gears a little bit into enterprise software, a ton of AI is going on in back office stuff that you probably don't think about, but you think it just needs to work. So often the example here is sort of improving the customer experience or process automation. So did anyone travel on business to get here? Anyone going to submit a receipt for their time or energy being spent here? So, a few of you may do that through a company called Workday, right? And you may take a picture of that receipt and expect that to just sort of magically understand and do OCR to understand, the amount, the date, the time, where you were for submission and approval. Now, behind the scenes, there's actually thousands of different kinds of receipts. The amount is often not in the same place. So OCR may be able to get a certain percentage of those, but behind the scenes, the reality of receipts is that I take a picture and it's kind of crunkled up, right? And so the business problem here was they wanted to improve the percentage of receipts that got recognized automatically and improve that customer experience at the end of the day by reducing the manual time to enter that information. And they needed to improve the text recognition by improving where the bounding box was localizing to on those receipts. So in reality, people take pictures of receipts that are like crumpled and hard to read and have bad lighting. And so often OCR gets tricked. And so by doing sort of large-scale job training here, they were able to improve the percentage of the receipts that they recognize. And so now this system that we have all started to take for granted actually works a much higher percentage of the time. So this is a fun shift as well in robotics. So has anyone seen these robots going up and down the stores of Walmart recently? So they're rolled out in about 50 different stores. They're going to be growing quite largely. And what happens is a couple times a day, there are these robots by Boston Nova Robotics, and they go up and down Walmart stores, and they take pictures of what's happening on the shelves and whether or not something is properly stocked. And so, again, it comes down to a visual recognition classifier around improving that store experience, around making sure that people can find what they're looking for. And in this case, they need to delineate what does a stock shelf look like and what does an empty shelf look like, right? So that they can understand which products are being understocked, how can they improve the fully stocked shelves, and ultimately improve my experience when I'm going in to find cereal, it's in the right place where it should be, and I can buy it. So in this case, right, from the robot's point of view, what this looks like is shelves, and understanding not just what does a category look like, right, and making sure that you can tag the hundreds of thousands of different products that they have in store against the taxonomy and do that efficiently for every single product that they have in store in a set amount of time so that humans can go and restock those shelves, right, very efficiently several times a day. Another example of what this looks like, making sure that they can grab what the price is, what it looks like. So similar example in agriculture technology around increasing crop yield, increasing productivity, reducing labor costs here. There's a company called Resson, and they do data-driven farming. And so what they're trying to figure out is how do you reduce the cost of pesticides? How can you spray less onto food? And so often what happens is pesticides get sprayed all over the field, like super broadly, when really it may only need to be sprayed in certain sort of narrow areas. And that comes down to determining whether or not a piece of fruit, in this case grapes, actually have bugs on it or not. And so getting really in the sort of nitty-gritty details of whether or not something is damaged and needs to be sprayed ahead of time. Anyways, as you can see, we have use cases from all different kinds of industries. I'm showing a lot of image-based ones here because they demo well, but we also have audio and text-based use cases quite heavily. That actually represents sort of a huge percentage of what we do. I'll go into an audio example here now, which is Blue Canoe. So if you've ever tried to learn a second language, something I've struggled with tremendously. I find it hard. And in this case, they developed an app here for people who were learning English. And the app you sort of play for a couple minutes a day. You can get instant feedback and track your progress over time. And so they were paying University of Washington linguistics students to actually rate what people were saying from an audio clip. And they were paying them $21 an hour. However, what they were sort of experimenting with, they couldn't scale their business doing that. There were only so many University of Washington linguistic grad students who were willing to actually sort of participate here. And so they needed to sort of scale up. And that they were sort of concerned about making sure that they could still get really high quality feedback on the accuracy of what people were saying. So in this case here, you play the clip, and then it asks you some follow-up questions about that audio recording, which is a micro task. And you're able to sort of, it says, hey, were you able to listen to the audio recording? Were you able to focus on the final word of the recording? And then determine that final word. And so what this allowed them to do was have a huge increase in the amount of savings, also scale their business, and also train models to recognize that at scale. And what they found is that there was no statistical difference between the feedback from the contributors all over the world and from the grad students in the University of Washington when they were able to break it down into these micro tasks. So I could go on and on and on about examples all day long. We've got about 200 different clients, but these are sort of 3 things to remember in summary, which is start with a business value. Make sure that you break down into small and specific component of a process that you're trying to improve. Get real with the data. Don't use academic data. Don't use fake data. Make sure that the production data that you have is consistent with the data that you will want to use in the real world deployment. And make sure that you're actively learning and improving your model over time. Thank you so much.
Thank you. Great talk and great timing, because now we have time for a couple questions from the audience.
Yeah.
On the county pool thing that you were explaining, how did AI come into play to solve that problem?
Sorry, which one?
The Earth deal?
Oh, OmniEarth?
Just repeat the question.
Yeah. So your question was about OmniEarth and how did AI come into play to solve that one. So in this case, what they were doing was distinguishing, I think it was 4 different classifiers. It was whether or not someone had a pool in your backyard, yes or no. Let me go back, I can explain more specifically. So there were sort of 4 visual classifiers that they started off with here. So the blue is areas or parcels of land that had a pool in your backyard. The yellow is, do you have solar panels on your roof or not? Because that's an indicator that inside your house you may have like low flow toilets, or you may be sort of more likely to conserve water. And then the pink is you had both a pool in your backyard and solar panels. And they built this out for all different visual classifiers.
So the collection of this data came from
USGS. This is open source USGS data. Yeah, anyone can get this. Yeah.
You mentioned you have sort of customers across like the industry spectrum. From your standpoint, are some industries sort of more cutting edge than others? Who are the leaders who are left, who's kind of falling behind in terms of, is retailing ahead of, asset management? So who are like the leading?
Yeah. So the question is, what industries are ahead or behind in terms of taking advantage of AI and sort of deploying stuff? From our customer set, I would say it has less to do with the industry and more about sort of the sophistication or tech forwardness of the company. So it often has to do with like e-commerce based companies or tech forward companies tend to have sort of use cases that are sort of forward. But what's interesting is actually not so much industry specific, because they'll have use cases across almost every part of their business, right? So you take a company like Uber as an example, right? You think of them like, oh, very tech forward, autonomous driving, that must be where all the AI is. But actually, right, they have AI across all sorts of different parts of their business in support ticket classification or sort of back office things. So there's a huge range. Yeah.
Mine's good follow. So what, in your opinion, what industry is moving a little bit more slowly than you personally think it should, depending on some greater forces, like business forces, like shipping and logistics? Everybody talks about it, but there's never any case studies.
Yeah, I mean, so we have case studies and customers across the industry. When I first got to Figure 8, my first suggestion was, oh God, we're a startup, we should be focused. Let's focus on one industry and like really nail that. And then I looked at the data and it was like, nope, like we have customers, we have such a long tail of industries. I would say regulated industries tend to be a little bit farther behind, which is like fairly standard. So, medical is a little bit farther behind than in e-commerce, just in terms of volume of our clients. But yeah.
But what surprises you that's not moving as fast as you think it should?
It surprises me it surprises me how much people start with the data and not the business, and how much like, oh, cool there is, and sort of how much energy goes into sort of creating models and building stuff that just gets sit on the shelf because you've sort of forgotten to start with the solving a business problem. So I give this talk quite a bit. Yeah.
So my question is around the career advice you got about solving hard problems, which is what I'm supposed to do, like startup within a big corporate. So my question is, sometimes when, before you try the problem, of course I agree that you need to start with a business problem. One of the biggest problems we have is that, are we collecting the right data?
Yeah.
So how have your experience related in this area? What is your journey to finding out, are we even collecting the right data in the first place?
Yeah, so I think oftentimes you're not collecting the right data. that's sort of what happens, I think, most of the time, is that you realize once you finally settle on a business problem, you don't have any data that's related to solving that business problem. It's pretty common. But I don't think that gives you a hall pass. It means, hey, go figure out how to collect that data. Go figure out the stakeholders that you need to convince, whose boss's boss's boss, right, often in a large company, to get the right data collected. And that ends up being the much harder problem than actually building the classifier itself, often, in my experience. So, yeah.
Feeding off of that, you say both start with the business problem that you need to solve. Does Figure 8 as a company do consulting with companies and advise them on what data to gather, or do they have the data and then start from there?
So most of our customers come to us with a data set, but that's not always the case. Oftentimes our customers will come to us, and an easy example is, hey, I want to build a chatbot, but I don't have a history of chat logs or intents and entities recognized. So we can often sort of create synthetic data for you. The challenge there is often when you're creating data sort of synthetically, it doesn't always match kind of what people are actually going to say. So that's a really sort of iterative process where you need to have a very tight human in the loop process when you're deploying something in the real world. But it's very possible to kind of get jump started with synthetically created data. Yeah.
Does acquiring external data help for optimizing business problems?
Yeah. The question is, does acquiring external data help in solving business problems? Yes and no. So sometimes it's like not possible to purchase the data that you need. Like it doesn't exist anywhere. So sometimes it's possible to acquire. Sometimes, oh, there's an awesome data set sitting over here. Let me just buy it. Sometimes people won't sell it to you, even if it's there. So it can help, but not always. Yeah, it depends. So some of our clients come to us and they're data science teams and all they need is sort of data. Other folks come to us and they say, hey, please do everything end to end for us. We have a team of in-house data scientists that will build, create, and host models. Other times we'll build them in our partners. So we're partnered with IBM, we're partnered with Google AutoML, we're partnered with Amazon. So depending on where your stack lives, Microsoft, Salesforce as well. Yeah.
Scientists deployed for one of the use cases, and what will be your investment in terms of like take one of the key use cases where you can justify your investment in hardware, software, and the human being. That's the data scientist, or maybe a domain expert.
Yeah. So the question is, how many data scientists does it take to deploy this, and what's the investment?
Like for example, the current example.
Yeah. So in this use case, the data scientist, it was one. Her name was Shay Strong, and she's still a contact and professional colleague of mine. We're giving a talk next week actually, but it was one, right? Because the actual data science work itself isn't that sophisticated. The much harder problem is actually prepping, cleaning, organizing the data. I think this project, sort of soup to nuts, probably took her 3 to 4 weeks, including all the sort of data cleaning and access problems.
What will be the value of this particular solution?
This particular solution was hugely valuable to the state of California by helping the state of California reduce their water consumption. So it was valued in the millions or billions of dollars. Yeah. So that's what's so cool about this, right? Like one person with the right data and the right business problem, like, can really make a huge, huge impact. Because most people don't have water meters that are successfully monitoring them, or they're broken, or these systems were put in before water meters existed. Or oftentimes you have a leak that's not monitoring based on the water meter. Yeah, I thought so too. I was like, isn't there an easier way to do this? Yeah.
So in the real world, what I've seen is that one of the biggest challenges is that on the basis of requirements, the business problem usually changes.
Yeah.
So how do you manage that, the change management, when you're actually down the line in terms of actually building one?
Yeah, so the question is around change management, and hey, the reality is in the real world, the business problem changes, and it's a moving target, and so how do you handle that? I think that's making sure that, so I don't know if you're a data scientist or not, but making sure that you're very sort of close with the product owner or sort of the business program, and making sure you really understand the true nature of like what that end goal is of the requirement, and making sure that you understand, sort of what the appetite is for change, because often requirements change because there's some sort of external constraint, like, oh, well, we couldn't get the data, so now we're going to solve a different one. Or, oh, there's a new shiny thing. But to me, that actually meant it was a fairly low priority project if it's changing so much, or the business value wasn't super well understood. Yeah. All right,
So,
I think I'm out of time.
Yep, unfortunately, we let people go for lunch, but I want to thank Alyssa. It was a great talk. Thanks very much for your time and for taking some questions.
Absolutely. I'm here if anyone has more questions. Thank you.
Thanks, everybody.